Okay, now for some more fun stuff. So I showed you the response for a rising step. I showed you the response for a falling step. Okay, what I'm going to do now is just compose these two responses together and show you the response for a pulse. And in this particular situation, let us assume that the rising step is followed by the falling step much later. Okay, in other words, this is a very wide pulse. Okay, the time between the rising and falling edges of the pulse is very long for this current here. Okay, I'm dealing with the same Norton kind of circuit with the capacitor, and this is my node voltage VC, and I'm going to use these various kinds of inputs for the current. Okay, so for a pulse input, let me draw out a couple of axes so that we can look at the waveforms here. So this is T, this is 0, and these are my axes for the current. Then let me draw a couple of axes for the output voltage VC of T. Let me switch colors. Let me go to green. Okay, so the pulse is simply a rising step. So I start off with taking a jump at time t equals 0. Okay, let me take a jump to a DC value I. Okay, so I jump to value I. And then let us say I wait for a long period of time. And then let us say that I'm going to take a jump back down to 0 and go down here at time capital T. Okay, so here this is a rising step, and down here I have a falling step. Okay, so what I end up with is a pulse.